In this video, we're covering the end of course assessment practice test questions 21 through 40. I'm using the Florida virtual end of course geometry practice test, but you can actually use these practice questions for any final geometry exam. And so I'm going to do 20 questions from that test, and then in part 3 will be questions 41 through 60. So let's get started. Now questions 21 and 22 are actually a continuation of the same type questions from part 1, from questions 19 and 20, where we're actually comparing quadrilaterals. So question 21, we're asked, when comparing a square and a rectangle, one major difference is. And so let's look at each of these questions or these answers here. So for A, it says squares must have 90-degree angles. Rectangles do not have to have all 90-degree angles. And of course that is incorrect. Rectangles also have to have 90-degree angles. So let's look at B. It says squares have two sets of equal sides. Rectangles have only one set of parallel sides. Of course that is incorrect as well. A square has all equal sides, not just two sets. And rectangles have two sets of parallel sides. Let's look at C. Squares have four equal sides. Rectangles have two pairs of equal opposite sides. And of course, this would be the correct answer. So our correct answer is C, but let's just look at D. It says squares have diagonals that bisect each other. Rectangles have diagonals that are perpendicular. This is incorrect because squares have diagonals that bisect, but rectangles do not have diagonals that are perpendicular. All right, so let's move on. So this is just a matter of knowing the properties of these quadrilaterals. If you're not familiar with the properties, please go back to video 1, and I actually go over the properties of quadrilaterals and look at the timestamp for that actual overview of quadrilaterals. Let's move on to question 22. It says when comparing a trapezoid and a kite, one similarity is A, it says they both have congruent diagonals. Well, neither kites nor trapezoids have congruent diagonals, so that is not true. Part B, it says they both have at least one set of parallel sides. Well, trapezoids do have one set of parallel sides, but kites do not have any parallel sides. Let's look at C. It says they both have four congruent sides. Well, neither kites nor trapezoids have four congruent sides. That is a square or a rhombus. So let's look at D. It says they both have four sides, and so that's their only similarity. So this would be the only correct response for this question. And there we have it. Let's take a look at number 23. It says the coordinates of the three vertices of a square are A, -3, 5, B, 1, 7, and C, 3, 3. What are the coordinates of vertex D? So when you take your end of course test, you will be given a graph paper or a work folder with a grid on it where you could graph ordered pairs. So I'm going to pull up this graph here. And so the first thing we're going to do is just plot these points. So point A is -3, 5 here. B is 1, 7 right here, and C is 3, 3 right here. And so since the figure has to be a square, the opposite sides will have to be parallel and their adjacent sides will have to be perpendicular. So parallel opposite sides, adjacent sides, which are sides next to each other, will have to be perpendicular, or their slopes will have to be opposite reciprocals. But I'm actually just going to use the slope to draw the fourth point. So if I find the slope between A and B, I could count from C to find my fourth point. So let's just go ahead and find the slope from A to B. So remember, rise over run. So I have to get from A to B, I have to go up 1, 2. So my rise is 2. Then I count over 1, 2, 3, 4. So my run is 4. So the slope of this from point A to B is 2 over 4. I'm not going to reduce it because I need to count the same amount of spaces. And so if I start from point C, okay, I can do the reverse. So the slope is positive 2 over 4, but If I change this to negative 2 over 4, I can actually count down 1, 2, and then to the left 1, 2, 3. Can't count 1, 2, 3, 4, and that will give me the fourth point here. And so you can actually check this. All right, and then to check it, so your slopes, so my slope here, if I go from, let me label this point D. And if I wanted to check this, I could find the slope from D to C. So let's check it. Use a different color. Go up, 1, 2, rises 2, run, 1, 2, 3, 4. So I have the same slope there. If you wanted to check the BC, it should be perpendicular, meaning the slope should be the opposite reciprocal. So it should actually be 4 over 2 negative. So let's check that as well. So we should count down 1, 2, 3, 4. So my run would be negative 4, or my rise would be negative 4. And then I will count over 1, 2. So my slope, or that run, would be 2. So the opposite reciprocal is negative 4 over 2. And that does work. And so that fourth point there, D, is at the ordered pair, or at the coordinates negative 1, 1. So that would be C. Let's take a look at number 24. It's a similar problem where we have ordered pairs. It says the coordinates of vertices of quadrilateral ABCD are given. So we have them right here. The coordinates of vertices of quadrilateral PQRS is right here. Which statement is correct? So the first thing we want to do is plot these points. So I'm going to plot quadrilateral ABCD. So negative 8, 8 would be right here. Negative 4, 8, that is B. C, negative 4, 4 will be here. And D is negative 8, 4. And I actually plotted A incorrectly. I plotted it on 9, and it should be here. All right. I bet you were probably like, I hope she sees that before she gets to the end of the problem. So A, B, C, D, and I'm trying to draw a straight line. Okay. Let me just make it a little neater. Let's do this. Okay. All right, and so next we're going to plot PQRS. So P is negative 10, 10, which would be here. Q is negative 2, 10, here. P, Q. C is negative, no, R is negative 2, 2. And S is negative 10, 2. All right, so let's just connect these lines here. Trying to draw them straight, not really working. So now let's analyze our answer choices here. It says quadrilateral ABCD is similar to quadrilateral PQRS. That is actually true. Adjacent sides are perpendicular since these sides are vertical and horizontal. We could see that. So that means that the segments meet at a 90-degree angle. Therefore, the quadrilaterals are similar. So we found our answer at A. No need to keep going. Okay, so for 25 and 26, we're looking at convex and concave polygons. So for 25, it says, what type of polygon is shown? Let's count the number of sides first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has 11 sides, and so we could eliminate A and B because a nonagon has 9 sides. But C and D both say that it is a hendecagon. But is it convex or concave? It will actually be concave. And you can say that a polygon that is concave has dents, so you can kind of see these dents here. So that's the way I like to look at it. It's concave, it has caves, it has dents. All right. Number 26, it says Athena described the figure below as convex irregular polygon. So irregular is correct because remember irregular, that means that all sides are not congruent or equal. You can clearly see that these sides are smaller. But it asks the question, is she correct? No, she is not correct. So we can eliminate that. And is it a heptagon? Heptagon has 7 sides. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. No, it is not a heptagon. So C and D says no, it is concave. No, it is regular. We know that it is not regular because all of the sides are not congruent. So it have to be C because it is also concave. We have this dent right here. Let's take a look at number 27. It says a rectangle and a horizontal line segment are shown. What is the resulting object when the rectangle is rotated around the horizontal line segment? So we can actually use the process of elimination here. We know that it would not be a sphere because we have this straight piece here. So, and then also it says it's rotated around, so meaning it's going to have a curve to it. And so we can eliminate the last two because these two are not curved. So it would have to be just by process of elimination that first shape here. Number 28. So we're given this figure here and we're asked to find the measure of angle F. So quite a few things we need to do first. And so we have a polygon here. We need to find the sum of all of the interior angles of the polygon. So with any question like this, if you're given angles and a polygon, start by thinking about the interior angles theorem of the polygon, which is, or sum of interior angles rather, which is 180 times n minus 2. All right. So, and n is the number of sides. All right. So the number of sides we have here, 1, 2, 3, 4, 5, 6. 6 minus 2, 180 times 4. And that will give me 720. So all of these angles added together, angles A, B, C, D, E, and F added together will equal 720. So if I want to find the measure of angle F, which is here, I want to actually find X first. So since I know that all the angles together equal, or the sum is equal to 720, by using this sum theorem, I could combine everything. So I'm going to add 10x minus 4 plus 10x minus 4. So that will give me 20x minus 8 and 5x plus 8 and 5x plus 8. That is going to give me, now I'm just trying to save space here, so I'm adding everything before I actually write some of it down. That is 10x plus 16. So a lot of algebra in geometry. And then I'm going to add the 128 and 34. Plus 134 plus 128. All of that equals 720. So basically I'm just adding all of these together and setting it equal to 720. Now I'm going to combine my like terms. Again, just algebra skills, solving equations. So 20x, 10x, that's 30x. Those are all of my x's I see. So that's 30x. And then combining negative 8 plus 16 plus 134 plus 128. That will give me 270. And then I'm left with this wonderful two-step equation. Subtracting 270. 30x. So 720 minus 270 is 450. One-step equation left, divide by 30. X is equal to 450 divided by 30. That is 15. So x is equal to 15. Now I could find the measure of angle F. Where is F? It is, let me erase all of this a little neater. So F is here. So I could just plug in x. So I found that x is 10. X is 15, I'm sorry. Let me actually make this a little neater here. 15. x is 15. So I'm taking x and plugging it in. 10 times 15 minus 4. So 10 times 15 is 150, and 150 minus 4, that is 146. And so the measure of angle F is 146. So anytime you're given a polygon and you're given angles and you have to find one of the angles, you can always use the polygon angle sum theorem to find the amount or the measure of all of the interior angles and set what you have equal to that amount. Alright, so let's move on. Number 29, it says the vertices of pentagon LMPQR are, so I'm not going to read all of these numbers here, and the coordinates of pentagon after two translations are right here. How was LMPQR translated to create L sub 1, N sub 1, P sub 1, Q sub 1, and R sub 1? So you're basically trying to figure out what happens from one ordered pair to the next. First, let's examine our x values, and we're looking at translation, so take it one step at a time. So what happens from L to L sub 1? Let's see. Our x value is 4, and it goes from 4 to -5. So from 4 to -5, that is, you're subtracting 9, because 4 minus 9 gives me -5. Let's see what happens with M. So from 5 to, where's my M sub 1? -4. Again, you're subtracting 9 from 8. So P to P sub 1 to -1, you're subtracting 9. And so from 6 to -3, again, so on all of these, you're subtracting 9. So our x value, we know it goes along with our x-axis, and so that's a horizontal translation, or left or right. So remember, x, left or right, and y value is up and down. So just think about your axes. So x-axis is left and right, y-axis is up and down, and so we can actually eliminate actually all of these actually. So because we know that with our x values, we go to the left 9 units. This says to the right, this says to the left by 1, this says to the right. So all of those we can actually eliminate, but let's just double check here. For A, it says and 1 unit up. So let's look at our y values. So from -2 for our L, then our L sub 1. From -2 to -1, that is adding 1. From -2 to, where's our M? -1, again, you're adding 1. -5 to -4, adding 1. -7 to -6, you're adding 1. And -4 to -3, you're adding 1. So y values, that is up and down, so that would be 1 unit up. So my answer would be A. Number 30, it says the figure shows the initial position of an arrow used in a board game. Points L, M, N, O, P, Q, R, and S represent locations on the game board. Between which two letters will the arrow point after rotating 185 degrees counterclockwise about the center? So counterclockwise, we know with the clock, the handle goes, if we have handles, this is my makeshift clock, the handles go this way. They go around this way. So counterclockwise will of course be the opposite direction. So it goes to the left. So counterclockwise goes back to the left. So 185 degrees. Remember, a circle is 360, right? So a full circle, half of that is 180. So that's what I think of when I think of degrees. So half of that is 180. So that would be the halfway point. So let's count back halfway through. I'm counting to the opposite side here. So this will be at 180 counterclockwise. But it says 185 degrees. So that means it would be in between these two letters right here, R and Q. And that would be my answer. If it would have said clockwise, we would have gone around the other way and it actually would have ended up between R and S. But since it said counterclockwise, we go back to the left. Just a little further past that 180 degree mark. Let's take a look at number 31. It says rectangles A and B are similar rectangles, so meaning their sides are proportional. The length of the diagonal of rectangle A is 13 inches, and the length of the diagonal of rectangle B is 6.5 inches. What could be the length and width of both rectangle A and rectangle B? So if we look at their relationship, the diagonal, we go from 13 to 6.5. So we can say that their relationship, B is 1/2 of A, because 6.5 is half of 13. And so since that is their relationship, the size of the rectangle would also have to be half of the length, because they are similar. So let's see which one matches. Let's look at A. It says rectangle A is 512 and rectangle B is 2.56. So, okay, rectangle B is half. So 2.5 is half of 5 and 6 is half of 12. So my answer is there. The rest of them do not fit. 3 is not half of 4. 2 is not half of 7. And so that is my answer. That rectangle is half, or the dimensions are half. Number 32, it says, Brennan is making a poster for the drama club's new production. It is a regular pentagon with side lengths of 12 inches. So regular pentagon, side length of 12 inches. The school wants to put up a giant replica of the poster during athletic events. So a similar poster, because it's going to be a replica. So it says if the length of each side is 8 times the original. Okay. How many times larger is the area of the replica than the area of the original? So a little extra information in here that we don't need. We don't need to know that the side lengths are 12, because the question is asking how many times larger is the area of the replica. So the original poster, it's 12 inches, so it tells us that, but the important piece is that the length is 8 times the original. Okay, so since the scale factor between the poster and its replica is 8, because we have 8 right here, we just square the scale factor to find the ratio between the area of the similar figure. So we just take 8, raise it to the second power, and it is 64. Alright, 64 times larger. If it would have said volume, you would have just cubed it. So to figure out the area, that scale, you would just square it. So our answer here is 64. Number 33 says the toddler section in a park is in the shape of a trapezoid. The parallel sides of the section measure 10 by 14 meters. The distance between the parallel sides is 8 meters as shown below. The section was remodeled to have an area of 96 square units more than the original area. What change in the dimensions of the trapezoid was made to create the remodeled area? So first, it says the section was remodeled to have an area that is 96 units more than the original. So let's go ahead and find the area of this figure here. The original figure. So remember, area of a trapezoid is 1/2 base times, 1/2 height times base 1 plus base 2. So, or you may see it as 1/2 times base 1 plus base 2 times the height on the end. It's the same thing. So 1/2, so our height, remember, is always perpendicular to the base, so our height is 8. And then base 1 and base 2, that would be 10 and 14 and 10. Multiply that through. 1/2 times 8 is 4. 14 plus 10 is 24. 4 times 24 is 96. Alright, so the area of this figure, or the original figure, is 96 meters squared. So now let's analyze this. It says this section was remodeled to have an area that is 96 more units than the original. So let's see what happens. So the height was doubled. So let's look at A. If the height is doubled, that would mean that the height would be 16, right? So let's try the area if the height is 16. So area equals 1/2. The height is 16 because it's doubled. So it was 8, now it's 16. And then with the same base, 1/2 times 16 is 8. 10 plus 4 is 24. And 8 times 24 gives me 192. Okay, so how does that compare to, so that's meters squared. How does that compare to the 96? Let's subtract 96. 192 minus 96 is actually 96, and so the height was doubled. So this actually works. It says the section was remodeled to have an area that's 96 more units than the original area. What change in the dimensions of the trapezoid was made to create it. So if we add 96 to this original 96, we get 192. So the height was doubled. So if that would not have worked, you would have went to part B and said the height was multiplied by 4. You would have plugged in 32 for your height to see if that worked, if 96 was a different number, and so forth. You would have for C, if that didn't work, the length of the parallel sides and the height were doubled. So you would have gone through and looked at each scenario, but it just so happened that A worked out, so it was a little less work, but I plugged in 16 because it said the height was double, and I found that it's 96 more units than our original 96, so the height was doubled. Number 34 says the right triangular flag of a sports club was designed to have a base length of 4 feet and a height of 6 feet. For a sports event, the club made a new flag by doubling the base and the height of the flag. The area of the new flag is blank times larger than the original flag. So let's find the area of each flag. So the original flag here designed was 4 feet for the base and 6 feet for the height. So if I draw this, remember the height is always perpendicular to the base. So the base is 4 and the height is 6. I know this is not drawing a scale. It looks like an equilateral triangle, but I'm just drawing a triangle. And so height is 6, base is 4. So let's find the area of this triangle. 1/2 base times height. 1/2 base is 4, height is 6. And I really didn't need the picture, but I just wanted to show you. So 1/2 times 4 times 6 is 12. So first triangle is 12 feet, or the first flag. And then it was doubled. The base says for a sporting event, the club made a new flag by doubling the base and the height. So the base would now be 8 and the height is 12. So area equals 1/2 8 times 12. 8 times 12 is 96, and half of 96 is 48, or I just multiply straight across. So that is 48 feet squared. So how do they relate? It goes from 12 to 48. So it says the area of the new flag is blank times larger than the original flag. That would be 4 times larger. You could find that by saying 12 times what is 48? So 12 times 4 is 48, or you could divide 48 by 12. Either way, that would give you 4. So we're going to say that it is 4 times larger. Number 35, it says Gina has designed 2 triangular flower beds as shown below. And we have triangle ABC and triangle PQR. And it asks us which statement is true for the 2 flower beds. And so if we're looking at these flower beds, I'm noticing here that I have congruence marks with the angles here. So angle A is congruent to angle Q, and angle C is congruent to angle P because they both have the congruence marks. And we have 10 feet, so they have 2 congruent angles and a congruent side. So we could say that this is angle, angle, or angle, angle side, angle, angle, side. So these triangles are congruent by angle, angle, side, actually. So let's look at these two statements. So anytime you have triangles with congruence marks, and you're trying to compare the two triangles, always think about these properties. Angle, side, 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 angle, angle, side. So think about those four properties, and I forgot side, angle, side. So two triangles, and there you see that they have congruence marks. Think about your properties there. Alright, so it says they have different areas. So if the flower beds are congruent, they should have the same area. So that would not be true because we just determined that these two flower beds are congruent because it is, let me write it out, angle, angle, side. This is how they are congruent. So B, it says they have the same perimeter. Yes, this is true because congruent figures would have identical or the same perimeter. So my answer would be B. Let's look at the other two. It says the length of side BC is equal to 10 feet. Since A and C are congruent, are not congruent, they're opposite sides. The sides opposite these angles cannot be congruent. So if we look at A right here and C right here, across is 10, right, from C. A and C are not congruent, so A could not be 10 because the two angles are not congruent. And if we look at D, the length of side PQ are equal to 10 feet. This is just not enough information to determine this. This is PQ, not enough information. So I always just look through all of my answer choices just to make sure I pick the correct one, double checking my work here. So these triangles are congruent by angle, angle, side, so they would have the same perimeter. Number 37 says match each building with the geometric shapes that can be used to model it. And so we're looking at these shapes here. We have a cone, and right here we have cylinders, no pyramid, and no rectangular prism. For the second figure, we have these shapes here. Those are cylinders. And then right here we have rectangular prism. Alright, this last figure down here we have the top. It looks like these are straight here. So that would be a pyramid. Pyramid only has that one base. And then looks like we have some cylinders here. And we also have a cone, cylinders and a cone right here. Do we have a rectangular prism? Yes, we have several rectangular prisms, so this actually is made up of all the shapes here, and so we have completed this question here. Let's take a look at number 38. It says Gina stores her toys in a container that has a cylindrical body and a conical lid as shown below. So the bottom is a cylinder and the top is a cone. And it says she wants to cover the entire exterior portion of the container with paper. How much paper in square feet would she need? So exterior would be on the outside, of course, and so that would be the surface area. So remember, volume is on the inside. Surface area would be all the material on the outside. So if you think about like a canned good, it would be the label of a canned good, but we have this cone here as well. So we want to find a surface area, but if we look here, this is on the inside, this circular piece here, because she wants to cover the exterior of the container. This little circle piece will actually be on the inside, the top of this circle. So we have to take that into consideration when we're finding the surface area. We want to find the surface area of the cone and the cylinder, but we want to take out this portion here. So surface area of a cylinder is, formula is 2 pi r times h plus 2 pi r squared. And what do you know about that pi r squared? Well, hopefully you know that that is the formula for area of a circle. Area equals pi r squared. So what would this 2 come from? This 2 comes from the fact that there are two circles in a cylinder, right? You got this top circle here and you got this bottom circle. So that's where that 2 comes from. If we don't need one of those circles, we're going to subtract, actually, one of the area of the circles. So we're subtracting pi r squared because this would be pi r squared, the area of this circle, and this would also be pi r squared. We don't need this pi r squared, so we're subtracting that before we find the surface area. So 2 pi r times h plus, this is 2, this is like a 1. Remember, we don't see the 1 in front. We don't put the 1. So 2 minus 1 is 1, so that would just be pi r squared. So now we could just plug in our given information. And if you notice your answers are in terms of pi, make sure you always check that, because it may save you some work. So in this case, since our answers are in terms of pi, we don't have to multiply pi through. Alright, so r is for radius. Our radius is here. It goes from the center to the edge of that circle. Height is 3 plus pi r squared. Again, our radius is 2. So I'm just simplifying this. 2 times 2 is 4. 4 times 3 is 12. So 12 pi plus 2 squared is 4. That is 4 pi. And so the surface area of this cylinder is 16 pi. So that's only a portion of what we need. Now we have to find the surface area of the cone. So that formula is, for the cone, pi r times L plus pi r squared. And again, that pi r squared comes from, hopefully you remember, this circular piece right here. So when you find the surface area of a cone or anything with a circle or cylinder, that pi r squared comes from the area of that cone. So we don't need the area of, the area of the circle. We don't need the area of this circle here because, as we mentioned before, it is on the inside. We want the exterior. So we only want this piece here. So we can actually subtract the area of the circle here, right? This circle here. So we don't need that. 1 pi r squared minus 1 pi r squared just cancels out. And so we're just going to use this formula here because we don't need that circle. So pi times r. R is the radius. Again, that is 2. Hopefully you remember that L stands for slant height. So not the perpendicular height. So this is our slant height right here of 2. And we just simplify that. I didn't mean to put radius here. Okay, so 2 times 2 is 4, and that is 4 pi. Now we found the area, or the surface area of both, so now we could just combine them. 16 plus 4 is 20, so my answer is 20 pi. Number 39, it says, almost done with part 2. It says a ball of diameter 20 fits exactly inside a cylindrical container as shown below. The maximum volume of liquid that can be poured into the cylindrical container when empty is blank. Use 3.14 for pi. And so they give us the information about this ball to help us find the volume of the cylinder. So remember, volume of a cylinder is volume equals pi r squared times h. So we need the radius and the height. And so this will actually give us that information, because if you think about the diameter of a ball, the diameter goes across, right? From one edge of the circle to the next, or in this case a sphere. So my diameter would be 20, so that would mean the height of this cylinder would also be 20. All right? And then we need the radius, so we have the height. We also need the radius. If we know the diameter is 20, the radius will have to be half of that, which is 10. So we have the information that we need. Let's just plug it in. 3.14 times r squared, so that's 10 squared, times h, which is the height. Multiplying that through, so 3.14 times 100. 10 squared is 100, so that's 20. 3.14 times, so 100 times 20, that is 2,000. Multiplying that through. And of course I could have just multiplied this straight across. I don't know why I'm doing all of this. I could have multiplied 3.14 times 100 times 20 and gotten this. All right, so it should be 6,280 for the volume, and that is it. 6,280 for the volume of the cylinder when it is empty. All right, we finally reached the last problem for part 2. So let's go ahead and complete number 40. It says the volume of two similar solids is 1,331 meters cubed and 729 meters cubed. The surface area of the larger solid is 605 meters squared. What is the surface area in square meters of the smaller solid? So a little bit of work here. So the first thing we want to do, since the volume is cubed, we want to find the scale factor of the similar solids by taking a cube root. All right, so we're taking a cube root because volume is cubed, and we're doing this to find the scale factor because they are similar. All right, so the cube root of 1,331 is 11. All right, and the cube root of 729, and this is really raising it to the 1/3 power. So in your calculators, depending on which one you're using, you do have, some calculators do have the cube root, but I think it's easier to always remember you can just take raise it to the 1/2 power. So you can do 130, put the number in, hit your caret key or your exponent key, and in parentheses to the 1/3 power. All right, or you can just remember your cube roots. And so, all right, so their scale factor between the two solids is 11 to 9. So now we're going to compare the scale factor to get the surface area. So we're going to set up a proportion to do that because it says what is the surface area. So our scale factors are 11 over 9, and you might ask, why is she squaring this? I'm squaring it because we want to compare the surface area. Area is squared. So volume is cubed, area is squared. And so the volume of, not the volume, the area of the largest solid is 605. And so on the other side at the top, since 11, that's my largest scale, portion of the scale factor. That goes with the larger solid there. And we want to find the surface area of the smaller one. We don't know what that is, and so we plug in x. So simplifying, I get 121 over 81 is equal to 605 over x. I'm going to cross multiply. 121x is equal to 605 times 81. 605 times 81 is 49,005. And this should be an x here. And just solving using, again, algebra skills. And so x is equal to 405. And so that would be the surface area of that smaller solid. All right, and so that was the last problem for part 2. All right, so we've reached the end of our review for part 2. The related videos are, of course, parts 1 and 3 for the geometry end of course assessment practice test. Another related video is the algebra end of course assessment if you want to just brush up on some of those skills. If you haven't already, please like, comment, share, and subscribe. And also click the bell so you can be notified when I post new content. And again, I want to thank you for reviewing with me.